Alright, I'm going to go through this truss problem, solving for all the reaction forces, all the members, and whether they are in tension or compression. So we're going to start off is we are going to need to draw in our reaction forces. So right here I have F-A-Y and I have F-A-X, and over here I have F-C-Y. My three reaction forces, two at the pin, one at the roller. Okay, and so the first thing I do is I look to see, this is my only force being applied on it. Very simple one. Starting really simple. So there are no X forces acting on it. So this is just going to be zero. It's going to drop out. I won't even look at this after we get done here. So I've got that. So all I have one force coming down here and I have two over here. So I need to set a pivot point. That's going to be my pivot point. I do my pivot point at the pin. And so then I do my, that's going to be my pivot point, so these two go away. So all I'm going to have are two moments, this one and this one. Okay, my known one, the 960 pounds, that is going in a clockwise direction, so I'm going to put that on the left. So I have a moment at B equal to my moment at C over here. Only have two, and they're equal to each other because this one is going clockwise, this one is going counterclockwise. I replace my moments with force and distance. So I have 960 times my distance. Okay, I'm going from here to my pin. Perpendicular distance is going to be 8. And over here I have my distance here is the whole thing. So I got 14 FCY. Multiply these out and divide by 14, and let's see what I get. I get 960 times 8 divided by 14, and that gives me 548.6. So that would be this guy right here. $548.6 going upwards. Okay, so now I come back here. That was 0. So I have my y, and these two going upwards have to equal this one going downwards. So sum of the forces in the y, I have 548.6 minus 960 plus my FAY. Bring this to subtract these, and what I end up with is FAY is equal to 411.4. Okay, so there's my three reaction forces. One of them is 0. One of them goes away. So now what I need is well, first I need to find the angles. So let's get my angles here. I need to know this angle. So to find my angles, I use inverse string. So my angle, theta at A is equal to the inverse tangent of, this is my angle, I'm going my opposite, which is 10, over my adjacent, which is 8. And my theta at C, inverse tangent of, again, it's going to be 10, but this time it's going to be what's left over out of here, which is 8 from 14, so it's going to be 6. Okay, and so when I do that, let me do one just to check. Inverse tangent. Okay, so my A is 51.3, and my C is 59. Degrees. Okay, now I got my angles. So now what I need to do is I need to do free body diagrams. So I'm going to draw I need to do one for each point. So when I do this, I always say, and I have that Word document which explains how I go through it. So I do free body diagrams. I always start at the roller. Why not? You got to pick one, pick the simple one. So I'm going to draw a free body diagram right here of my roller. So basically, I've got my center point. This is at C, free body diagram. I've got 548.6 going upward. I have, and when I draw my free body diagrams, all my arrows are pointing away, except for the ones that I know. So this one is, I'm going to label this FCD, CD, and then I have this one, FBC, with my angle of 59. Squeeze that in there. So here's my free body diagram for point C, at pivot point C. So joint C, I'm sorry. And so now what I need to do is I just need to plug into this. And so so what I want to do is I'm going to start with the Y, because that's the one that I know. So I'm going to solve for FBC. I can't solve for CD because I've got no number that goes with it, because this is pure Y, nothing else. So what I do is I'm going to do the sum of the forces in the Y direction equals 0. I have 548.6 going upward, so that's positive. And then I need the Y component of this. I only want the Y part, so think of this as being like the right triangle we were talking about. So you want this part, you want the vertical part of this force. And so we're going to use our formula from that. So it's going to be F, this is BC, and because it's the Y part, it's going to be sine of our angle 59. So this is, again, so this is FBC, I'm sorry, F is my force going up, sorry, my reaction force, and CY and going here. So I just plug that in. So if I bring that to the other side, then what that gives me is, this is going to become negative. So a negative 548.6 divided by the sine of 59. And when I do the math on that, let's see if I can get that. 548.6 divided by 59 sine equals, yep, that agrees that. So that is going to be a negative 640. And because it's negative, that means it is compression. So I'm going to come up here, let's put that in. That is going to be 640 in compression. Okay? So that's I found that one. So now we're going to go and find this next one. Put that over here. I'm going to need some more real estate in a little bit. But I can do it here. So now I'm going to do sum of the forces in the x direction equals 0. Actually, I'm going to come way down here. Sum of the forces in the x direction equals 0. Okay? So I have this one, and this is pointing this way, so it is a negative FCD going in that direction, negative FCD. This is where the direction of the arrow is giving you negatives and positive signs. This was going into positive Y. This is going into positive Y. This is going to negative X. Now, this is now, because it's compression, is not going to be a negative 640 in that same direction. Or I could have changed the direction of the arrow and made it positive. You'll see when I get to my number here. So this is going to be negative FCD, and this is the tricky part. It is going, well, let's write this out first. So that's going to be, I know that number. This is now F. What it's going to be is F cosine of BC, FCD. So this is going to be my force, I know. So it's going to be 640 cosine of 59. But, okay, so is it I got to check to see, is this going to be a plus sign or a negative sign? This is where the mistakes happen. This is where people get wrong answers. I got to look at this. I'm going in this direction. That is a negative x, but it's a negative number. So I could think of it as like minus a minus, which ends up being a plus. Okay? If I had changed the sign, if I changed the direction of the arrow and left this positive, then it would still be going, now it would be a positive number going in the positive x direction. This gets a little confusing, but this is where you really have to slow down and think about it. Look at those arrows and see what direction they're pointing. Okay, so this becomes a positive number. This is a negative. I bring it to the other side, and this becomes positive. And so I just get FCD equals 640 cosine of 59. Okay? And so when I do that, 640 times 59 cosine, I get, perfect, 329.6, so we'll round that up to 330 because I'm running out of room. So that makes, this becomes right here 330. Okay? So if I do this, and because it's a positive number, that means it's in tension. 330 in tension. Okay? So we got that. I think I got space to do this one I'm going to do next because it's quick and easy. So I can still do that here. And then I'll need another slide. So, so now I do a free body diagram. That was for C. This is for D. So what I have is I have going upward. I have F, B, D. I have going this way, F, C, D, and going this way, F, A, D. Okay? Three things. Force here, force here, force here. So these are my three members right here, free body diagram. And so here's the interesting part. So I look at this. If I do sum of the forces in the y direction equals 0, how many y forces are here? Oh, wait. There's only one, FBD. So that equals FBD. So this is 0. This is a free body diagram. I know you're saying, but wait, there's 960 pounds up here pushing down. How can this not be affecting this? We are looking at a free body diagram. We are looking at just that point. We don't care what's over here, here, or here. All we care is what's acting right here, what these are. This, there's no force acting on it. There's no force acting on it here. So it is 0. Now this means it's 0 for this situation. For these members have no weight, and there's 960 pounds pushing up here. If I push something over here, then it might be, if I had something down here, then it would be something, but right now, so that's 0. Crazy, huh? This one is awesome. This is so easy to do. That's why I always tell people this is the one, because you can't get it, you almost can't get it wrong. And now, so look at this. Sum of the forces in the x direction equals 0. Okay? FCD, do we know FCD? Heck yeah, we just solved for it over here. This is 330. So this is going to be 330 going that way. I got this one going the other way, minus FAD, bring that to the other side, so FAD equals 330 in tension, because they have to balance each other out. So this is also 330 in tension. And this is the point I'm trying to make here. When you're doing these 5-member truss, however many forces on it, this kind of thing, this one goes so easy. If there is, and in my write-up on how to do it, it says for the middle joint, if there is no y force acting on the point, the vertical member is 0. So this is really easy. Whatever's here is here. and whatever's here is either 0, or if there's a force down here, it would be equal to that. Otherwise, that's it. Okay? So now we have, all we got left is this guy. And I'm going to have to add me a new slide over here. And wait. I'm going to copy this into one so you can see it, because I'm going to have to come back to it. No, I can't. All right. Shoot. We're just going to squeeze it in here. I can see it off on the side. You just can't. So what I have is one last free body diagram. And that would be at A. And so that one, this one has going upward. That was 411.4. And then I had this one going up here, FAB. I have this one, FAD. And if there was an X force, there would be something here. Remember, that went away? If there was something, I would have an arrow here. If there was a force in the X direction applying to it. But I don't. And that angle was 51.3. Oh, and since I got a full screen, we'll do it both ways. Awesome! All right. So we know FAD. We just found that. That is 330. So I know I've got an X force. I've got a Y force. So I could solve for this either using sine or cosine. I'm going to do it both ways so that we can compare it. So basically what I have is sum of the forces in Y equals 0. So I have this one going upward, 4114.4, going upward. This is in the positive Y direction. So I'm going to go, that's a positive. And then that would be FAB sine of 51.3. Down here, sum of the forces in the X direction equals 0. Okay? This is going in the positive X. So that is 330. This is going, I'm sorry, that's going into negative X. My bad. That is no, it's going positive X. And this is also going into positive X. So that's a plus. And now we have FAB cosine 51.3. Okay? Again, this is equal to the horizontal part of this force. This is equal to the vertical part of that force. Okay? And so I'll just rewrite these. So FAB equals negative 411.4, because I brought it to the other side, divided by sine of 51.3, and FAB equals negative 330, because I brought it to the other side, divided by cosine 51.3. And you can see how I did that, right? I moved this to the other side, it went negative, and then I divided both sides by the cosine of 51.3. This was just to get me something so I knew exactly what I was punching into my calculator. Okay, let's see how we did. 411.4, whoops, 411.4 divided by 51.3 sine equals, I get a negative 527. I'm going to put an extra .15. I'm going extra decimals here because I did that in the wrong place. I'm sorry. Okay, up here, I just did the sine one. So a negative 527.15, and down here, 330 divided by 51.3 cosine, and this one I get negative 527.79. Okay, so they were really close. It all depends on how many decimals you carry stuff. Because I did 51.3, I'm closer. If I had done 51 degrees, which I sometimes do, and I'm trying to save myself numbers, then they would be farther apart. So, but you can see, so this is also compression. And so if we go back to our original, I can go back to this slide, and I'll just say 527. That way, that's exactly what I got. So that is a completed truss now. I have all the members, whether they're tension or compression, and my angles and my reaction forces, and we never had to do point B. You generally don't. You start with the start with the roller, then move to the center because those numbers carry over, and then when you get over here, you have just one left. And if there's more forces, that just adds a little more work over here. But that's basically it. You do that the same way every single time.